On June 30th, 1908, something hit Siberia with the force of 1,000 atomic bombs. But there was no crater, no confirmed impact site, and no wreckage. The record only says this. At 7:14 in the morning, across a remote stretch of central Siberia near the Tunguska River, 80 million trees fell in a radial pattern. They didn't burn, they snapped. Witnesses, reindeer herders scattered across hundreds of miles, reported a flash brighter than the sun. The blast wave knocked people down from distances of 40 miles. And yet, when investigators finally reached the site 16 years later, they found no impact crater, no meteorite fragments, just forest, stripped and flattened, pointing toward a mystery that has fractured science ever since. Here's the first question we need to answer. What exactly hit Siberia that morning? The conventional theory, the one most textbooks teach, is a meteor. A rocky object from space, roughly 10 to 20 meters across, traveling at 27,000 kilometers per hour. The impact released energy equivalent to 10 to 15 megatons of TNT. For context, the atomic bomb dropped on Hiroshima was 15 kilotons. This was 1,000 times more powerful. But here's what troubles investigators. The Chicxulub impact in Mexico, which killed the dinosaurs 66 million years ago, left a crater 180 kilometers wide. The Barringer crater in Arizona, formed 50,000 years ago by a much smaller meteor, is still visible. It's a hole in the ground, a scar. Yet at Tunguska, despite the catastrophic energy release, searchers found only disturbed soil and scorched trees. The ground appeared relatively intact. This discrepancy opened a second question. If a meteor didn't hit, what did? In 1934, Soviet scientist Leonid Kulik led the first major expedition to the site. He was searching for a meteorite, a prize that would prove the impact hypothesis. He found nothing. No fragments, no metallic residue, just the forest, still lying down like wheat after a scythe. Kulik died believing the answer was buried somewhere beneath the moss and permafrost. The answer, he thought, was still waiting. So what was the alternative? In the 1960s, researchers proposed a radical theory. The meteor had exploded in midair, an airburst, not a ground impact, but a detonation occurring several kilometers above the forest. The shock wave, traveling faster than sound, would have flattened trees in all directions without creating a crater. The meteor itself would have vaporized completely, leaving no wreckage. It's a plausible explanation. The physics work. But acceptance of the airburst theory raises a third question. How confident are we in this explanation? The record shows that no meteorite fragments, iron, stone, or otherwise, were ever recovered from the impact zone. Not one confirmed piece. In 1927, a small metallic particle was found in soil samples, but its origin was disputed. Some researchers claimed it was extraterrestrial. Others argued it was terrestrial contamination from the expedition itself. In 1958, an Italian researcher named Ernesto Balducci proposed something different. Not a meteor at all, but a comet. A dirty snowball of ice and rock, traveling even faster than a meteor, would leave even less trace. It would vaporize completely in the atmosphere, releasing its energy as a massive explosion. No crater, no fragments, only the blast. The theory gained traction among some scientists, but it remained unproven. Which brings us to the fourth question. Could something even stranger have occurred? In the 1970s, fringe researchers began floating unconventional hypotheses. A black hole passing through Earth's atmosphere. A fusion bomb detonated by an extraterrestrial civilization. A natural nuclear explosion triggered by uranium deposits underground. The record shows these theories were published in obscure journals and presented at conferences. None found mainstream support. None could be tested. But there's a fifth question that might matter more. Why do we still care? A century has passed. Satellites now map Earth's surface with unprecedented precision. We've identified over 190 confirmed impact craters worldwide. We've studied meteorite composition. We understand atmospheric physics. And yet Tunguska remains partially mysterious. Not because the mystery is unsolvable, but because the evidence was scattered, contaminated, or lost before modern science could examine it properly. The scientific consensus today leans heavily toward the meteor airburst model. The physics align. The energy calculations fit the observed destruction. Computer simulations of an airburst match the treefall pattern documented by researchers. Most planetary scientists consider the case functionally closed. The answer, in their view, has been found. Yet the file remains open in one crucial sense. Absolute proof has never been delivered. No recovered meteorite, no definitive chemical signature. No piece of physical evidence that says, without equivocation, this is what happened. We have a theory that fits the facts, but we do not have the fact itself. The distinction matters to investigators. A good theory is not the same as solved. What we do know with certainty is this. On June 30th, 1908, a cosmic object struck Earth's atmosphere above central Siberia. It released energy equivalent to thousands of conventional bombs. It flattened an area larger than a small country. It killed reindeer herds and possibly humans. Exact casualty figures were never recorded. And then it vanished, leaving behind only questions and a forest that took a century to grow back. So, returning to the original question, what was the Tunguska event? Based on the evidence available, the witness testimonies, the forest damage patterns, the absence of a crater, and the physics of atmospheric explosions, the record points to a meteor or comet that detonated in midair. Not a ground impact, an airburst. This explains the destruction without requiring an impact site. It answers why there was no crater. It fits what we know. But mysteries endure when evidence disappears. Tunguska happened in one of Earth's most remote regions, in an era before aerial photography, before systematic investigation protocols, before we knew to preserve a crime scene. The first researchers arrived 16 years after the event. By then, the forest had begun to heal. Witnesses had scattered. The window for collecting hard evidence had closed. What remained were accounts, patterns, and inference. Today, Tunguska stands as a reminder of something crucial to investigators. The first hours matter. The first days matter. Contamination, decay, and human error compound over time. A mystery that could have been solved with one recovered meteorite fragment became, through circumstance and delay, a case that required a century of argument. The answer was always there. We just arrived too late to collect it cleanly. The Tunguska event was likely a cosmic impact. The evidence taken together supports that conclusion. But likely and proven remain different things in the record. And until we find the artifact, the meteorite fragment, the chemical signature, the irrefutable physical proof, the file will carry a single notation: unsolved in absolute terms, solved in practical ones. A mystery that science has answered, even if the answer came too late to be verified with certainty. If there's a lesson here, it's this. Some mysteries endure not because they are unsolvable, but because we failed to preserve them when we had the chance. Tunguska scorched Siberia and vanished. We built a theory around the scars. It's a good theory. It's probably right. But the proof, the meteorite, the fragment, the physical evidence, remains lost to time. Subscribe. Every week brings a new unsolved case where the truth is waiting in the details.